Everything I had went up in flames. My lonely way.
Now, have you done this numerical?
No, sir.
No, sir.
No, sir.
Then do the numerical. The distance, this is based on center of mass of two particle system. I think we have done it. Okay, just check. The distance between center of carbon and oxygen. Distance between center of carbon and oxygen. Atoms in a carbon monoxide molecule, CO, in a carbon monoxide molecule is 1.13 into 10 to the power minus 10 meter. Locate the center of mass of the molecule. Locate center of mass of molecule related to carbon atom. So this is carbon.
Sir, can you repeat the whole question again? Okay. No.
It's there in the chat.
Between the center of carbon and oxygen atoms in a carbon monoxide, CO.
It's there in the chat.
Molecule is 1.13 into 10 to the power minus 10 meter. Locate the center of mass of molecule. Locate the center of mass of the molecule. Locate the center of mass of the molecule relative to the carbon atom. Relative to the carbon atom.
Sir, so means we have to take carbon as the origin in this case.
Yeah, anyone should be at the origin. So here I am taking carbon at the origin.
Sir, but then what did you mean by relative to carbon atom?
With respect to carbon atom.
Oh, okay.
Okay. So this is carbon. Its mass is 12 unit. Atomic mass unit 12. This is oxygen, 16 atomic mass unit. Distance between them is 1.13 into 10 to the power minus 10. So center of mass will be somewhere here, right?
Yes, sir.
This is smaller one. Here carbon must be a little smaller one. Okay, so this somewhere here center of mass will come. Now it's only x-axis, so we can write center of mass R, Cm, C equal to, okay, M1. This is only x-axis, so I'm taking x. X center of mass is equal to
M1 R1 plus
M1 x1 plus
M2
x2 divided by M1 plus M2.
Sir, M2 x2, right? You wrote M1 x2.
M2 x2. So first one is M1. This is M2. So M1 is at the origin itself, therefore 0. Distance from the origin, that's called x1, okay? So that is 0. M2 into M2 means what?
16.
M1 let us mark 12. 12
Yes,
into 0. M2 is 16 into x2 is how much? From here to here
into
distance.
10 raised to minus 10.
Yeah. 1.13 into 10 to the power minus 10. 1.13 into 10 to the power minus 10 divided by M1 plus M2. M1 plus M2 means 12 plus
28.
16, 28. See, that's what here I am not converting its unit. atomic mass unit. If you convert it to kilogram also, unit will cancel out. Okay. Otherwise, don't confuse. Here I am converting into meter, this atomic mass unit. Because here, atomic mass unit cancels. Then what is remaining now? Answer 6.45 into 10 to the power minus 11 meter from carbon. If you're taking carbon here, you have to minus 1.13 minus that value and you have to write. That should I have taken from the origin. This is a position of center of mass. Any doubt?
Sir, how would have been how would you solve this if they asked us related to oxygen atom?
Oxygen should be at the origin.
Okay.
Otherwise, you can do one thing, 1.16 10 to the power minus 2 minus 10 minus this value. That will be from oxygen.
Okay, sir.
Isn't it?
Yes, sir.
Can I continue to next numerical?
Yes, sir.
Locate center of mass of a system of three particles. Locate center of mass of a system of three particles of masses 1 kilogram, 2 kilogram and 3 kilogram. 1 kilogram, 2 kilogram and 3 kilogram are placed at the corners of an equilateral triangle of side 1 meter. Look here how we are going to do it. So there is an equilateral triangle here, okay? Equilateral triangle we need. This is M1. At the origin, I'm placing M1. Say this is M2 and this is M3. Here it is 1 kilo. This is 2 kilo and this is 3 kilo. See, only if 1 kilo and 2 kilo, center of mass will come somewhere here, right?
Yes, sir.
When there is 3 kilo, it will slightly shift to this point. Somewhere here it will come, right?
Yes, sir.
So actually we need to find out this one. From origin to that point, what is the center of mass? This is what we want to find out. This has x-axis as well as y-axis.
Y-axis.
So two answers will come here. X-axis we have to find out, y-axis we have to find out. Clear? This is what we are going to find out here. You understood?
Yes, sir.
Listen. So first we'll go for x-axis. X center of mass is equal to m1 x1 plus m2 x2 plus m3 x3 divided by m1 plus m2 plus m3. So x centimeters is equal, m1 is 1 kilo, but position is 0. m2 plus m2 is 2 kilo. So what is the distance of m2 here? 1 meter, right?
Yes, sir.
Yes, sir.
Each side is 1 meter, so 1 plus m3, 3. What is the x-axis of m3?
1.
Here, right? That is 1. Not 1. How it
Sir,
will come?
0.5. It will be 0.5.
Half meter, sir. Half meter.
0.5. Okay.
Yeah, because that's a median, right?
Yeah. So 0.5 or half, anything you can take there. Divided by 1 plus 2 plus 3. 1 plus 2 plus 3. First you find out XCM. Then you will go for Y. First you finish it.
Sir, 0.75.
Yes, very good. 0.75. 0.74, 0.58.
75.
But I'm getting
0.5.
0.58.
5.8.
Check once
How?
again.
0.5.
1 into 0, 0.
Sir, 0.58, sir.
2 into 1,
Yes,
2
5.
plus 1.5 divided by 2 plus 1.5, 3.5.
I understand,
Divided
sir.
by, correct?
Yes, sir. 3.5 by 6, 0.58.
Is it correct?
Yes, sir, I
Yes, sir.
understand.
Okay, 0.58 centimeter, right? It's giving centimeter.
Meter.
Now we need Y. Y of center of mass is equal to M1Y1 plus M2Y2 plus M3Y3 divided by M1 plus M2 plus M3. So here what is M1? Again, 0. M1 is 1 into 0 because it's at origin.
Yes, sir.
M2, that's also on
Into
x-axis.
0.
So 2
Zero.
into 0 plus M3, 3. Now this has y-axis. M3 has y-axis.
Yes, sir.
This one. We have to find out this point now. What is this? How much?
0.5.
Here to
Sir,
here,
we
what
can-
is the distance?
Sir, we can find through Pythagoras theorem the
Pythagoras
height,
theorem.
right?
Find out and tell me. Pythagoras theorem. Tell me how much will come. Using Pythagoras theorem, you have to find out that. Here to here.
Root 3 by
Root 3 by 2. Very good. Root 3 by 2 will come. This is 0.5. This distance we have to find out. Okay, this is 1 meter. It's an equilateral triangle. From this data, we can find out this one, Pythagoras theorem. I think everybody knows that Pythagoras theorem, right?
Yes, sir.
Yes, sir.
sir.
Yeah. And we can find out, you will get root 3 by 2. So into root 3 by 2 divided by 1 plus 2 plus 3. That means 6, isn't it? Find out.
Sir, root 3 by 4.
Root 3.
Root 3 by 4. Can you solve it and tell me root 3 by 4? 0.43, right?
Yes, sir. 0.4.
Now along x-axis, it will come around 0.58. See, this is middle is 0.5. Somewhere here it will come. Y-axis, x-axis. Y-axis 0.43. Okay. So somewhere here 0.43 will come. So center of mass will come somewhere here for this system. Okay. Then this is the resultant of it. Magnitude, if you want, this way have to write. This is R. So position vector R is equal to, you can write 0.58 meter I plus 0.43 meter J. Isn't it? This is the way you can write the answer. And if you want exact magnitude, then you can take square root of 0.58
So, why are you
squared plus
calculating R?
43 squared.
So, why are you calculating R?
See, actually it has two axes, x-axis and y-axis, right?
Yes, sir.
Suppose this is only coordinates we have now. Suppose they are asking, calculate the magnitude of R, position vector.
Yes, sir. Okay, okay.
Then you have to go this way. This is the coordinates. But what is the magnitude
Yes,
of the position vector to center of mass? Then you have to calculate this. So put in bracket, only if they ask you calculate. Clear?
Yes, sir.
Is this over?
Yes, sir.
Then we can go to next topic, moment of inertia. Moment. I told you always moment means rotation. Okay, moment of inertia. Moment of inertia. So, first chapter we studied inertia. A body which is at rest will remain in a state of rest. It has a tendency to remain in a state of rest. Body which in motion is a tendency to move. So for a heavier body, you have to exert more force to bring into motion because that has more inertia. A body, heavier body which is traveling with a velocity, you have to exert more opposing force to bring to rest because that has more inertia. So inertia depending on mass. Moment of inertia means inertia of a rotating body. Just imagine Earth is rotating. Very high moment of inertia Earth has. So this moment of inertia of a rotating body, not just depending on mass, it depending on mass distribution also. For example, you take an axis like this, okay? And take a disc, metal disc, 10 kilo. And just rotate. You can see it will rotate and stop after some time. Just think of moment of inertia. Means how long it stays. That will tell you moment of inertia. More the time it rotates, you can say more the moment of inertia. Quickly if it stops, less the moment of inertia. Now what you can do,
Sir, if
same
it has
thing.
less mass, it will rotate more, right? The disc?
No, less. Less mass means quickly it will come to rest.
Oh, okay.
Clear? Right.
Yes.
Now you take this is a disc 10 kilo. Now same 10 kilo disc, I'm melting and making a ring. That means complete mass distribution only at the rings, right? See now all masses at the end. And this I'm just connecting with the 4 strings and rotating it. Which case it will have more moment of inertia? This case or this case?
So second
The
case.
second case.
Second case, moment of inertia will be more. You can see that will rotate more time. Example, seeing machine, right? Seeing machine, that wheel. They pull it and it keep on rotating for longer time. That is a moment of inertia. This is the idea of moment of inertia. Once we can say it's a storage of rotation energy. If you just pull it, it will keep on rotating for longer time. This is using in cars, machines, rotating machines and all. The rotational drive will last for longer time if moment of inertia is more. Flywheel, example. You can say it's a toy car. Just push on to the floor and keep it. You can see car runs faster. You open it and see there's a big heavy wheel inside. So when you're pushing it, you're making that wheel to rotate at a high moment of inertia. So that wheel when rotate one time, there's a small wheels that will rotate 10 times. That's what this is moving faster. You understood the idea and application of moment of inertia?
Yes,
Yes.
sir.
So moment of inertia, not only mass distribution, how far it is from the axis of rotation. That also depends moment of inertia. You can see that. Bicycle,
Sir,
okay? Why we are keeping the spokes for the bicycle like this? We can make a single disc, right? Because now heaviness will be more here. So moment of inertia will be more. So you can easily ride your bicycle. That will push you forward more easily. But here if complete disc, if you are taking, the rotation will be less. You can try making a cycle like that. Clear?
yes,
Yes,
sir.
sir.
It's all mechanical
Yes, sir.
engineering. Write down. Moment of inertia. Moment of inertia can be defined as, write down how it is defined. Moment of inertia can be defined as, so moment of inertia means inertia of a rotating body. Moment of inertia can be defined as the product of mass of a particle, the product of mass of a particle, the product of mass of a particle and the square of and the square of distance from. The square of distance from. Square of the distance from. The axis of rotation. The axis of rotation to the mass. To the mass. Axis of rotation to the mass. Let m is the mass of the particle. Let m is the mass of the particle. R is the distance from axis of rotation to the particle. R is the distance from axis of rotation to the particle. Then moment of inertia can be written as I is equal to mr
Axis
squared.
of rotation.
R is the distance from the axis of rotation to the particle. Then moment of inertia can be written as I is equal to mr squared. Have you written this?
Yes, sir.
Yes, sir.
Next one, moment
sir.
of inertia of a rigid body. Moment of inertia of a rigid body. Moment of inertia of a rigid body. Moment of inertia of a rigid body. This rigid body consists of large number of particles, right?
Yes,
Large
yes,
number
sir.
of particles this rigid body consists of.
Yes, sir.
So we have to imagine this is M1, position vector R1. Okay. Then let us consider another particle M2, position vector R2. Then another particle M3. Distance from axis of rotation to that point is R3. M3, R3. Like that large number of particles we can imagine, isn't it? Mn, Rn. So many particles we can imagine like that. If it is like the total moment of inertia, I is equal to m1 r1 squared plus m2 r2 squared plus m3 r3 squared plus mn rn squared, or mathematically we can write sigma. Sigma means addition. M-I-R-I squared. I value can be 1 to n. See, first you substitute 1, 1, then 2, 2, 3, 3, 4, 4, and until n. Then add all things. That's the meaning of.
Sir, is n counted or till n only? Like before n
one?
we have to stop, or like can we write I as n or before n only? Like example, if n is 3, can we write I1 and I2? Should we write I3?
I is equal until 3. There are 3.
Okay.
M1 R1, M2 R2, M3 R3.
Okay.
Like, because a rigid body consists of large number of particles. So you write, let M1, M2, M3 Mn are the particle which constitute a rigid body, which constitute of a rigid body.
Sir, can you repeat?
Let M1, M2 Mn are the masses of the particle.